You know, we're surrounded by light and mirrors literally every single day, from that first look in the mirror in the morning to the glint of light off a shop window. But have you ever really stopped to think about how any of it actually works? Well, today, we're going to break down the simple and honestly fascinating science behind how we see the world.
Okay, so let's start with a really simple, everyday mystery. Go ahead, grab a spoon, and look at your reflection in the inside part. You know, the scoop. See that? You're upside down. Now flip it over, and you're right side up again. Why does that happen? It totally seems like some kind of magic trick, but it's pure physics. And I promise by the end of this, you'll know exactly what's going on.
All right, to solve our little spoon mystery, we first have to understand the main character in this whole story, light. And the thing about light is, it isn't random. Nope. It follows a very strict set of rules. And once you know those rules, you can pretty much predict exactly how it's going to behave. So, what even is light? At its most basic level, it's a form of energy. But here's the most important thing you need to remember. It always travels in straight lines. We call them rays. The only reason you can see anything, the screen, your hand, anything, is because light rays bounce off of it and travel in a perfectly straight line right into your eyes. That one single idea. It's the foundation for everything else we're about to talk about. Okay, so what happens when one of those straight lines of light smacks into something, like a mirror? Well, it reflects, obviously. But that reflection isn't just chaotic. It's governed by a simple, totally unbreakable law. This is the main rule of the game, so let's break it down real quick. This law is actually super intuitive. Just imagine throwing a tennis ball straight at a wall. It bounces straight back at you, right? But if you throw it at an angle, it bounces off at the exact same angle going the other way. Light does the exact same thing. The angle it comes in at, we call that the angle of incidence, is always equal to the angle it goes out at, the angle of reflection. Angle in equals angle out. It's as simple as that. Okay, so we've got our rule. Angle in equals angle out. Now let's look at the tools that use this rule to, well, kind of bend light and our whole perception of reality. Mirrors. And here's the thing. Not all mirrors are created equal. Their shape is everything. So you've basically got three main flavors of mirrors, and their shape decides what they do to light. First, there's the plain old plane mirror. It's perfectly flat. It just reflects light without messing with it. But things get way more interesting with curved mirrors. A concave mirror curves inward, like a cave. It takes light and focuses it all down to a single point. And then a convex mirror does the exact opposite. It curves outward and it scatters the light, spreading it all over the place.
And this brings us right back to our spoon. It's actually the perfect example of both of these curved mirrors. The inside, the part that you'd scoop soup with, that's a concave mirror. It focuses the light rays in a really specific way that flips the image, and that's why you're upside down. But the back of the spoon, that's a convex mirror. It scatters the light, which keeps your reflection right side up. And just like that, mystery solved.
So, you see, the rules themselves are actually pretty simple. But even when we understand them, there's a reason this stuff can still feel a little bit like magic. It's because trying to truly visualize all those little light rays bouncing around, well, it's tough. And for a long time, the way we've tried to learn this has had a pretty serious problem, a visualization gap.
I mean, if you learned this in school, you probably remember just staring at some flat diagram in a textbook, right? It shows one ray of light hitting one little point at one single angle. You can't move anything. You can't change the curve of the mirror. It's just static. And that makes it really hard to get an intuitive feel for how these laws work in the real world.
But what if you could? What if you could just have your own virtual lab where you could play with light, bend it however you want, and see the rules in action for yourself? Well, it turns out you can.
Take a look at this number, 1.8 billion. That's a huge number, and that's how many times people have stepped into this exact kind of virtual lab. But what is it?
That number, 1.8 billion, that's the number of times that students and curious people all over the planet have used this incredible tool called PhET interactive simulations, designed to let them explore concepts just like this one.
So what is this PhET thing? Okay, it's a project that was founded way back in 2002 by a Nobel Prize winner, Carl Wieman. And what they do is create these amazing, free, interactive simulations for science and math. The whole thing feels way more like a game than a textbook. And the entire point is to let you learn not by someone telling you the answer, but by you exploring and discovering the rules all on your own. You know, this really represents a fundamental shift in how we can think about learning. It's all about moving from just passively reading something to actively, participating in it. And that right there is the crucial difference. Instead of just memorizing the words angle in equals angle out, you can literally jump into a simulation, grab a virtual laser and see it happen. You can bend a mirror from concave to convex and watch in real time how the light responds. You don't just learn the rule, you feel the rule.
And this brings us all the way back to where we started, with a simple, everyday spoon. If we can turn the complex physics of reflection into something this intuitive, this playful, it really makes you wonder, doesn't it? What other huge, complex ideas are just sitting there, waiting to be understood? If we just started treating learning a little less like a lecture and a little more like a game.